This is Note Taking Guide 4.2 for Math 1. Today we're going to talk about how to decide if something is arithmetic or geometric. And we'll also create those arithmetic and geometric sequences or sets of numbers. So this first example over here says, for each sequence or each set of sequences, find the first 5 terms. Compare the arithmetic sequence and the geometric sequence, which one grows faster and when. It says the arithmetic sequence is f of 1 equals 2. The common difference is 3. So I want to remind you what this means right here, because we used this a couple of days ago, but you might have forgotten what that means. So really what that means, that f of 1 means the first term. So if the first term is 2 and the common difference is 3, then I know how to find the next term. The next term would be adding 3 to 2. So 2 plus 3 is 5, which is my next term. 5 plus 3 is 8, which is my next term. 8 plus 3 is 11, which is my next term. 11 plus 3 is 14. So I just found the first term, which they gave me, the second term, the third term, the fourth term, and the fifth term, which is what I was told I had to do, was to find the first 5 terms. So this is for the arithmetic sequence. So I'm going to write my arithmetic sequence answers down here. So I have 2 for the first term, 5 for the second term, 8 for the third term, 11 for the fourth term, and 14 for the fifth term. Now I'm going to do the same thing with my geometric sequence, but this time it's a common ratio. And if you remember, a common ratio means that we're multiplying by that, by that number instead of adding by that number. So this tells me my first term is 2. So now I have my common ratio of 3, which means I'm going to multiply by 3. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3, that's where I have to get out the calculator, is 162. Now that's 5 terms of my sequence, so I can now just go and write them in my table. The first term was 2, the second term was 6, then 18, 54, and 162. So the question was asked, which sequence grows faster? Well, you can look at these and see which one's growing faster. I mean, you start out with the same number right here for our first numbers. We start out as 2 in the arithmetic and in the geometric sequence. Here it only grows to be 5. Here it grows to be 6. So even on the first term, the geometric one is bigger. Then it grows to be 8, it grows to be 18. So the geometric sequence is getting bigger much faster. So which one grows faster? That would be the geometric one. And when? After the first term. It just keeps growing quicker and quicker after the first term. All right, and the last question says, which value do you think will be more, f of 100 or g of 100? So I really can tell just by my data there that g of 100 is going to be bigger because the geometric one is growing so much faster. All right, let's look at another example here. This time it says the table below represents a geometric sequence. Find the missing terms in the sequence showing your method. Geometric means that I multiply. I multiply by something to get to here. I multiply by the same something to get to here, and then I multiply by the same number to get to here. So I'm going to look at that 12 and think, well, what can I multiply by? So I'm going to just start with the number ones. So if I go 12 times 1, I get 12, which gets me this first term. If I do 12 times 1 again, I get 12 again. So I can't multiply by 1. It gives me 12 every single time. So let's try multiplying by 2. If I go 12 times 2, I get 24. If I do 24 times 2, I get 48. Oh, so that looks like it's going to work, right? I start with 12, then I get 24, then I get 48, and then so 48 times 2, that doesn't look like a 48, sorry. 48 times 2 is 96. So I just found my missing terms. This one's going to be 24, and this one's going to be 96. And again, the way I found those missing terms was I just started. I knew I had to start with 12, and I knew I had to multiply to get from one term to the next. So I just started with 12 times 1 and tried it out. It didn't work. It gave me 12s every single time. So then I moved up to timesing 12 times 2, and I just looked to see if that pattern would fit my pattern. It did, but if it wouldn't have, I would have moved up to 3 and tried 12 times 3 and then 12 times 4 until I found the pattern that would actually work. All right, on example 3 here, we are comparing arithmetic and geometric sequences. Here's my arithmetic one. I am moving up by adding 4, or I have a common difference of 4. This one is geometric. I have a common ratio of timesing by 3. So again, we can tell if it's arithmetic. We did this a couple of days ago. We can tell if it's arithmetic if we're adding to get from one number to the next. We can tell if it's geometric if we're multiplying by one number to get to the next. So let's see if we can figure out what we're doing here to get from one number to the next number. So 84 to 78, 78 to 72. Well, I don't think we're multiplying here because multiplying gets bigger or smaller quite quickly. So I think we're going to be adding a number, but in this case a negative number because we're getting smaller. So I'm just going to take that first number, 84, and I'm going to subtract 78 from it and see what I get. When I did that, I got 6. So I'm wondering if I'm going to subtract 6 to get from here to here. So then I'm going to try the 78 minus 6 and see if I get the 72, and I do. So because this was an add a negative 6 or subtract 6, this one is arithmetic. All right, the next one, I start with a 2, I go to a 4, I go to a 32. Now I can see right off the bat that that's probably multiplying because I'm getting big fast. So what am I multiplying to get from 2 to 8? I multiply by 4. What do I multiply by to get from 8 to 32? I multiply by 4. If you can't see that, you guys, you can always take this first number and divide it by the second number, or the second number and divide it by the first number, and it will help you find that ratio. So this is geometric because we're multiplying. All right, the next one here, 72 to 63. Well, that seems like it's going to be addition or subtraction because of the funny numbers. I don't think I can multiply 72 by a number to get to 63. But when I subtract, I get 9. So I subtracted 9 to get from 72 to 63. But here, I subtracted 10 to get from 63 to 53. So that's not going to be arithmetic because it's not the same number. So then how do I check to see if it's geometric? Because it could be geometric with like a fraction or something. So I'm going to just take the first number and divide it by the second number. So 72 divided by 63, that gives me 1.14. And then do 63 divided by 53, that gives me 1.18. So they're not the same. There's not a common ratio. So this one's actually going to be neither. It's not arithmetic or geometric. All right, this last one right here, I go from 36 to 12, from 12 to 4. I can see I'm dividing right off the bat. I can see that I'm dividing by 3. But if you remember, I can't divide by a number for it to be arithmetic. Geometric. I have to have it be multiplied by a number. So how do I tell which number it is that I'm multiplying by if it's divided by 3? Well, we can do it really simply on our calculator. Just by taking this previous number, the 12, and dividing it by the 36. So take the 12 on your calculator, divide it by 36, and your calculator is going to give you 1/3. and then do the 4 divided by the 12, it's going to give you 1/3 also. So because that number is 1/3, or it was divided by 3, but we have to write it as multiply by a number, this is geometric because I can find a number that I can multiply by for that pattern. All right, last one here is a fill in the blank. Find the missing value for each arithmetic or geometric sequence and state the constant difference or the constant ratio. So how do you get from 5 to 10? And then from 10 to 15, well, this looks like an add 5 to me. So I'm going to put 20 here and see if it makes sense. So 5, 10, 15, 20, 25, 30. I do agree with that. So my common difference on this, because the common difference is the number that we added to our sequence, then the common difference is 5. Now this other one here, how do I get from 20 to 10? Well, it could be subtract 10, but subtract 10 is not going to get me to a 2.5. So I actually think it's going to be divide by 2. But again, divide by 2 is the same as timesing by 1/2, which is the actual value that we need. We need what we multiplied by. So divide by 2 would get me to 10, divide by 2 would get me to 5, divide by 2 would get me to 2.5. So it is divide by 2, but my common ratio is actually the number I multiply by. So if I'm dividing by 2, I'm actually timesing by 1/2. So my common ratio is going to actually be 1/2 in that case. So again, how do I figure that out if I don't know? I take the 10 and I divide it by the 20. Or I take the 5 and I divide it by the 10, and it will give me that common ratio, how I get from one number to the next one. All right, you guys, good luck with your geometric and arithmetic sequences today. Thanks for watching.